Hello students and welcome to the next module. Students, in this particular module, we'll be learning Young's modulus, bulk modulus and modulus of rigidity. As I said, very important for understanding the numericals. Let us quickly go ahead. Young's modulus. Now students, Young's modulus was actually discovered by Professor Thomas Young. This particular person named this particular modulus with his own name. Now let us go ahead. Young's modulus capital Y is nothing but longitudinal stress upon longitudinal strain. Why longitudinal? Students, as we had seen in Young's modulus, we are going to talk about the length only. So let us go ahead. Now students, we have a wire having original length capital L. Also, this wire is attached to a load exerting a force F. The elongation or the change in dimension is going to be small l. So students, longitudinal stress is nothing but force upon area. So here the force is nothing but mg and the area, can you help me out? Yes, the area is going to be pi r square. Let us see what is longitudinal strain. Longitudinal strain is change in dimension upon original dimension. So here you can see change in length, that is small l. What will be there in the denominator? Original length, that is capital L. Now let us keep these two safe. Now students, we know that Young's modulus Y is going to be equal to longitudinal stress upon longitudinal strain. Therefore, Y becomes mg upon pi r square small l upon capital L. Now students, if I am just rearranging this and sprinkling a little bit of maths, what do I get? Mg capital L upon pi r square L. Now this, students, is a very important formula for numericals on Young's modulus. But students, there is one more formula to this which is comparatively more simpler to remember. So here we have Y is equals to, if you see mg was nothing but our force. So here we have force into length in the numerator. Further, we have pi r square. Now this pi r square was nothing but our area, students. So here we have area multiplied by small l. So students, if you read this starting from the numerator, this becomes Y is equals to F lal, right? Y is equals to F lal, that is nothing but F multiplied by capital L upon A multiplied by small l. You just have to remember that the capital L is going to be in the numerator. So no matter in which particular stream you go ahead, the formula for Young's modulus is going to be very fresh in your mind as F lal. So students, let us go ahead. Further, we see the SI units. Newton per meter square, CGS, dyne per centimeter square, and the dimensions are going to be the same as stress, that is M1, L minus 1, T minus 2. Let us go ahead, students, and go for the bulk modulus. Bulk modulus is related to volume. So here we have the original volume. If we are subjecting it to an external change in pressure or force, we get a reduction in volume by amount dV. So students, we get K is equals to volume stress upon volume strain. Now volume stress was nothing but force upon area, which is equal to dP, that is nothing but change in pressure. I repeat, it is not just P, students, it is the change in pressure that is given by dP. Also volume strain is nothing but by change in volume divided by original volume, that is nothing but dV upon capital V. Now students, if we are just substituting the values, what do we get? We get K is equals to dP upon dV upon V, that is nothing but K is equals to minus V dP upon dV. Minus sign. Students, the minus sign is denoting the reduction in volume. This is denoted by a minus sign because whatever the final volume is going to be lesser as compared to the original volume. Also students, the SI unit is Newton per meter square, CGS unit is dyne per centimeter square, and dimensions are M1, L minus 1, T minus 2. Now students, how to remember this particular formula? It's actually very funny but helps a lot. We all eat vada pav, right? So in the numerator, if you carefully see, we have VDP, that is nothing but our vada pav. In the denominator, we are going to have dV, that is nothing but our dahi vada. So K is equals to minus V dP upon dV is nothing but minus of vada pav upon dahi vada. So now students, being Indians, it is your sole and whole responsibility to remember this particular formula. Let us go ahead, students. Compressibility, one more very important entity when it comes to numericals. Compressibility is 1 upon K, that is the reciprocal of the bulk modulus is called a compressibility. So the units, the CGS unit and the dimensions are going to be exactly reversed. Now students, The final one, that is modulus of rigidity, denoted by eta. This is nothing but shear stress upon shear strain. So we have the diagram over here. Now shear stress was nothing but force upon area. So this particular value, force upon area, will be there in the numerator. Also students, shear strain is lateral displacement of any layer upon its perpendicular distance from the fixed layer. We have already done this part, right students? So quickly tell me, lateral displacement is nothing but PP dash, and the vertical distance, the perpendicular distance, is going to be equal to small h. Now students, this was equal to tan theta, and this in turn was equal to theta, as theta is usually small also if it is measured in radians. So students, modulus of rigidity eta becomes F upon A, which is the value of stress multiplied by 1 upon theta. That is nothing but strain. So this becomes F upon A theta. SI unit is Newton per meter square. CGS unit dyne per centimeter square, and dimensions are m1l minus 1 t minus 2. Students, these three are very important as far as the numericals are concerned. I'll see you in the next module with more such knowledge. Thank you.